to share with you guys some information about the power of photovoltaic cells. Because solar panels make So there's been a lot of hype surrounding renewable energy such as solar panels. So I'd like to explain some of the basics, physics, and hype about it. So why should we talk about solar? It's important because we live in a time with climate change and a lack of resources. So solar panels and solar energy is one of the most promising options on the market today. Oh, there's one. So the types of solar panels and solar energy. When we hear the word solar energy these days, we typically start to think of solar panels, but there's multiple different kinds. Of course, there's the common photovoltaic cells, the ones that use silicon or other types of materials to create electricity. Another type of energy generation is using solar water turbines, which basically means they focus light onto a source of water, and then they allow the boiling water to turn a turbine, which generates electricity. One less common method could be the use of thermoelectric devices. And thermoelectric devices take advantage of the Selbeck, Peltier, and the Thomson effects. Basically, when a piece of metal becomes relatively hot on one side and relatively cold on the other, it creates an electric current. And we can use that to get electricity. And there's another traditional method, which is spatial or water heating. Basically, you just put something in the sun and it heats up. That doesn't create electricity, so that's not. So for this presentation, I'm going to be focusing on photovoltaic cells because it's the most practical. Thermoelectric devices are too expensive for the same power generation. Spatial heating doesn't provide electricity, and solar water turbines require too large an area. So I'm going to talk about the physics of solar panels. Basically, they use the photoelectric effect. That means that the material emits electrons when light hits it. And when you connect the photoelectric effect and material exhibiting this effect to a circuit, you get electricity. Panel materials only exhibit the effect to some extent because the effect does not work for all waves and all materials. The effect depends on the frequency and the type of material, but generally waves with higher frequencies have more energy to knock off electrons. Now, the source of energy that we use is sunlight, and sunlight is considered to be white light, which is composed of all the light from the spectrum, from red with the lowest wavelength to purple with the highest wavelength. Naturally, higher energy colors like blue and purple have more energy to knock off electrons, while low energy lights such as red and orange are unlikely to knock off electrons off materials. Moreover, different materials have different spectral ranges, which means they require different light ranges to knock off electrons. Therefore, it's difficult to find one single material that can convert a large percentage of light into energy. Not to mention that there's inefficiencies in the circuitry that prevent 100% efficiency. As a result, most common affordable solar panels have efficiencies of roughly 10 to 20%. So there's still a lot of problems with solar, and there's one prevalent one, which is what do you do when the sun's away? One idea is to use lithium-ion batteries, charge them up during the day, and then use them up during the nighttime. But the problem with that is lithium-ion batteries cost a lot. They create a lot of carbon dioxide when producing them, and they release a lot of toxic chemicals into the environment when you throw them away. So using lithium-ion batteries could negate the cost-effective and environmentally beneficial impacts of using solar panels. We could also use power plants, but if we use power plants, we'd still be dependent on dirty coal and other sources of fossil fuel emissions. If we use wind power still has a lot of issues because like solar energy, it's very stop and go. So if we don't have wind, then we won't have electricity. As mentioned before, there's problems with efficiencies. Just from the solar panel itself, it can only generate about 10 to 20% of the light into electricity. And that's not mentioning the atmospheric interference, which is about 40%. So it only gives about 60% from the ground. One idea to improve the cost and efficiency problem is using a magnification system, which is where you focus a lot of mirrors or magnifying glasses onto a small photovoltaic cell. Although you do need a system to constantly direct it at the sun. Another idea is to use multi-layered panels, which is where you use multiple different materials to absorb different parts of the spectrum. Although this is still expensive and under low production, so it's not common yet. And there's also a lot of potential for solar because there's about a horsepower per square yard of direct sunlight without atmospheric interference. And the hope is that it will save carbon emissions. It's not carbon neutral, but technology can improve so that we do save carbon emissions. The best part about solar is probably the fact that you can use it for portable and personal power generation. The reason why it's so good is because currently most of our homes we get our energy from power plants, which are either hundreds or thousands of miles away. So just because of the resistance in the wires from us to the power plant, we lose about maybe 40 to 60% of the energy that's generated at the plant. So if we have our power source right above our homes, then we can have a low voltage drop so we get more energy out of it. And also, another potential is future costs. As of 2014, the price for the average solar panel is about 30% less than it was 10 years ago. With new technology and as we switch to clean energy, we will be able to have cheaper solar panels.
Go back to the first one. We got it. And then go to Windows.
So my two people are Archimedes and Galileo. So I'm going to be talking about Galileo Galilei, the famous astronomer and mathematician, as well as the famous inventor and mathematician Archimedes of Syracuse. Both of them made revolutionary discoveries in both the areas of mathematics and science. So Archimedes, he was born in 287 BCE and died in 212 BCE in Syracuse during the Second Punic War. Archimedes worked closely under King Hiram II and Prince Galen, who were the nobility of Sicily at the time. Well, in fact, we don't actually know what he looks like. They're all interpretations. He lived in Sicily while it was a Greek colony, and the most important part about him is he was believed to have influenced later mathematicians and scientists. He got his early education in the city of Alexandria, the home of the ancient world's largest library. So one of his most influential inventions was Archimedes' screw. Basically, it's just a screw-type device tightly put inside a pipe, and you can use this to raise water. It was first designed for getting water out of a boat, but it can now be used for farming and other applications. One of his most important contributions was the approximation of pi, where he basically used a polynomial approximation. So pi is the number that you get when you divide the circumference of a circle by its diameter. So he knew this, and he used the method of exhaustion to find the circumference. So his method was as follows. He started out by visualizing a triangle of perfect fit inside a circle, as well as a triangle of perfect fit outside the circle. So he knew that he could easily find the perimeter of any polygon, and he knew that the circumference of the circle would always be larger than this one and smaller than this one. So using that, he kept on reiterating it until he got really close to the circle. When Archimedes got to calculating with 96-sided polygons, he postulated that since the smaller polygons pi estimate was about 3 1/7, and the larger pi estimate was about 3 10/71, the real value must be in between. Archimedes' pi values were used until the 20th century when computers used this method of exhaustion to get to rest. One of the most famous stories with Archimedes was the story of the Golden Crown. So basically what happened was King Hiram II, he gave a lot of gold to the local blacksmiths to have a crown made for him. But when he received the crown back, he was suspicious that it wasn't pure gold. So the king gave Archimedes the task of finding out whether the crown was pure gold or not. Knowing the relative densities of gold and other metals, he knew that he was going to find the density. He could easily find the weight, but he didn't know how to find the volume. So one day, as he was allegedly thinking about the problem, he stepped into his bathtub and he noticed that the water level rose. He allegedly jumped out of the tub and said, "Eureka," which means "I found it," and he ran out naked into the street. He realized that he could find the volume of the crown by submerging the crown in water and finding the displacement volume. Archimedes found that the crown didn't match the density of gold, which was great for the king, but not so much for the blacksmith. Archimedes contributed to the small common sense method of finding volume by putting something into water. He also contributed to finding the volume of the sphere. The story of the Golden Crown wasn't his only crowning achievement. He also figured out the volume of the sphere. Archimedes did not know how to find the volume of an object that didn't have a flat surface. Volumes of shapes such as cylinders could be easily found since they already knew the area of the circle. However, a sphere surface is constantly changing. In order to solve this problem, he decided to visualize a sphere inside a cylinder of perfect fit, as shown in the diagram. Then he visualized cutting the Louis Vuitton rig with horizontal slices, which would look like this. So he added all the all the little slices together, and he found that the total area of the slices was equal to a cone that was the same dimensions of the cylinder. By subtracting the formula of a cone from the cylinder, he found 4/3 pi r squared. I'm going to go on to Galileo. He was born in 1564, and then he died in 1642 in Italy. He received his education in the University of Pisa, starting out as medicine, but then he went to mathematics. He had the study of the pendulum, and he basically found out that the arc length of the pendulum does not affect the period, it's the angle. And he was actually one of the first people to design a clock, although the first pendulum clock wasn't built till about half a century later. He was also really important in that he found that heavier objects do not accelerate faster than lighter ones. During this time period, most people accepted Aristotle's teachings, which was like he thought that heavier objects fall faster, but he didn't. He believed that when he was young, but then later on he started to question it. So one day he decided to drop a lighter and a heavier ball off the Tower of Pisa at the same time, and they landed at the same time. So after multiple iterations, he concluded that masses all experience the same acceleration. He also pursued astronomy. He first made this improved telescope after he looked at these Dutch eyeglasses, these Dutch telescopes that had a magnification about 3 times. He made some improvements, and he made a telescope that was about 10 times magnification. With that, he looked at the skies and he observed numerous celestial bodies before other people, including the phases of Venus, the rings of Saturn, some of the moons of Jupiter, and the appearance of sunspots. Using his astronomical observations, these observations led him to the conclusion that the Earth revolved around the Sun and not the other way around. He noticed this because the orbits of celestial bodies, as well as the phases of Venus, did not match the geocentric theories of the Church. He started to publish his findings despite Church warnings, and although he got warnings, he continued to write books, and he was eventually sentenced to heresy by the Church, and was given a life sentence. However, due to his old age and health, he was allowed to have house arrest instead. He continued to make observations and publish his works, and his findings spread throughout Europe. His findings helped convince the world that heliocentrism was the correct theory. And yeah, that's it.